In this lecture, we're going to explore what happens if our polymorphic or virtual function happens to live in different sections in our inheritance hierarchy. To drive the point home, we're going to be working on this inheritance hierarchy. Our base class is going to be shape, and we are going to derive from this and create an ellipse class. But what is going to happen if these virtual functions live in different sections in these different classes? For example, in the base class, we might put our virtual function in the public scope, and in our derived class, we're going to put that in our private section. We might switch these things off and have our virtual function, the base class, be in a private section, and have our virtual function be in a public section in our ellipse derived class. Now, the question is, what is going to happen if you try to use these objects directly without going through polymorphism? Or what is going to happen if you try to use a base pointer and call the most specific method in a derived class object through polymorphism? How is this going to play out? Well, if you go through a base pointer, the access specifier in the base class is going to win. That's what the compiler is going to look at, and it is going to ignore whatever access specifier you have in the derived class. But the compiler will still call the most specific method if you go through a base pointer to manage a derived class object that implements a virtual method that is overriding what we have in the base class. I hope this makes sense. So in this case, for example, if we go through a base shape pointer and manage an ellipse object, we will get this method here called. But notice that the access specifier in base is private, so we will get a compiler error if we try to use it like this. Because this is not accessible in the eyes of the shape class, we can't access this from the outside. But if we have a setup like this, the access specifier in the base class is public, so we can use this from the outside. If we go through a base pointer to manage an ellipse object, we will get this method here called, even if the access specifier in our derived class happens to be private. So again, if you go through a base pointer to manage a derived class object, the compiler is just going to look at the access specifier in the base class, and that's what it is going to follow to decide whether you can access things from the outside or not. This is the base idea here. Okay, so let's look at some code to really drive this home. We have our shape class. The virtual draw method is in the public scope, and we have another virtual method in the private scope of this class. Draw is in the public scope, func is in the private scope. If we inherit from this class and create our ellipse class, we're going to do public inheritance here. We're going to have our draw method in a private section in ellipse here, and the func virtual method is going to be in the public scope. So we are basically switching things off here. What was public in base is going to be private in derived. What was private in base is going to be public in derived. This is the setup we want to play with here. Okay, with that setup, this is something you need to keep in mind. When you call the virtual function through a base class pointer, the access specifier in the base class is going to determine whether the function is accessible regardless of the access specifier we have in our derived class. This is something you need to keep in mind. So if we do polymorphism and go through a base pointer, the access specifier for the virtual method in the base class is going to win, and it is going to decide whether we can access that method. But the compiler will still call the most specialized derived implementation if we go through polymorphism, and this is going to work. So in other words, the compiler is completely going to ignore the access specifier we have in our derived class, and we are still going to get polymorphic behavior. This is something you need to know. The access specifier in your derived class is really irrelevant if you are using polymorphism. If the access specifier is private in the base class, you want to be able to access your methods. If the access specifier in the base class is public, you're going to be able to access your method regardless of the access specifiers you have in your derived class in your inheritance hierarchy. This is the idea I am trying to drive home here. Okay, here is a simple example to try and drive this home. We know that the draw method is public, so we can call this through a base pointer. This is a smart pointer, and polymorphism is going to work with smart pointers. But if we try to go through the base pointer and access the func method, which is private in the base class, this is going to give us a compiler error. Now, we have an ellipse object created here. If we call our methods directly, we're going to get func called because it lives in the public scope in our derived class, but the draw method is not going to be callable because it lives in a private section of the ellipse class. Again, notice that here we are not going through a base pointer, so this is not going to give us polymorphic behavior. This is regular object accessing for a class, and this is the default behavior we know. This is going to do static binding here. But if we go through a base pointer, and if we create a row object of the shape class, and if we try to create a shape object by assigning an ellipse object to shape, you know what this is going to do? This is going to slice off all derived information, and it is only going to leave in shape information, and that's what we're going to get. If we call the draw method, this is going to be callable because we have a draw method which is public in the base class of shape. But if we call func, we're going to get an error because this is going to be private to the shape class here. This is something I really want you to keep in mind. Okay, another way to look at this is, in general, if a function call is done through dynamic binding or polymorphism, the access specifier in the base class is going to apply. If the call is done through static binding, the access specifier of the derived class is going to win. And here I am going to share my rule of thumb. Except for the base class, I mark all my other derived overrides as private because the access specifier in the base class is really relevant if we want to use polymorphism or dynamic binding in our C++ application. But notice that this is just my advice. This is my personal preference. You are free to explore and see what you like more because you are the expert when it comes to the project that you are working on with C++. Now that we know these things, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working directory. The current project is polymorphic functions and access specifiers. We are going to grab the code from our template project and use this. Let's put this in place. And I am going to grab the classes we are going to be using for this lecture. They are lying on my drive. We're going to use these as a starting point. The first one is going to be shape, which is going to have a virtual method called draw. The second one is going to be ellipse, and we're going to see how things play out if we change the access specifiers in base and derived and see how this really plays out with polymorphism. This is what we want to do here. So we are going to open this up in Visual Studio Code. Let's do that by dragging and dropping here. We are going to have our shape class. Let's open this up. We're going to have the class here. It's going to have two virtual methods. One is going to be draw, which is going to be living in the public section of this class. We are also going to have a virtual function called func, which is going to be living in a private section of this class. So this is the setup here. Once we hit our derived class, which is ellipse, we're going to switch things off. We are going to put the draw method override in a private section, and we're going to put our func method in a public section. Notice that these guys are overriding what we have in the base class, so they are overrides of both draw and func that we have in the base class, but we are flipping off the access specifier to see how these things play out. So this is what we want to play with in our program here. We are going to hop over in the main CPP file and clean things up a little bit. We're going to remove whatever it is we don't need here. We are going to include our ellipse class. I think this is the only include we need to put in here because ellipse is also going to bring in shape. Let's go there. You see that the ellipse header is including shape, so we don't need to explicitly include shape in the main CPP file here. And we will try and access things through the base pointer. We will be using smart pointers, so we are going to include the memory header because that's where our smart pointers live in the C++ standard library. I am going to put in the code we want to play with. We're going to create a shared pointer to shape, and this is going to be our base pointer, and we are going to use it to manage a derived object, which happens to be an ellipse. This is going to call our ellipse constructor here. Let's go back and see the constructor we have. We are going to take two double parameters and a string, which is going to be the description that we're going to forward up to the base part of us. I think we should change this to be std string view, and we are going to hop over to the CPP file and change this as well pretty quick. Std string view, and we are going to change things back in shape because we need to be consistent here. So std string view, and we're going to do the same in shape.cpp. Let's pass this through here. Std, now what did I do? We're going to say std string view, and this is going to do what we want. If we wait a minute, we should see our squiggly lines go away. But in the main CPP file, we have a problem because calling the func method through a base pointer, this is not going to work. Because we are going through a base pointer, the compiler is going to be using the access specifier we have in the base class. And if we go in the base class, we're going to see that func is in a private section, so we can't call that from the outside like we are doing here. That's why we have this compiler error. Hopefully this is making sense. If we try to build and pass this through GCC, we should get a compiler error, and the error is here. We're going to see that this method func is private within this context. We can't use it from the main CPP file. If we try to do that, we will get a big hard compiler error. But if we take this out, you're going to see that the draw method is going to be called from our code. And notice that it is public, and we have a specialization of that in our derived class. The specialization happens to be living in a private section. But notice what happens if we run the code. If we run the code, we're going to get polymorphic behavior because we will see this most specialized method called, even if we are going through a base pointer to call the draw method here. So I want you to keep an eye out for this. This is going to give us polymorphism. So let's build and show you that. We're going to pass this through GCC again. The build is going to be good. We're going to bring up a PowerShell window to really show this off, and we can run Rooster. Let's do that. And you're going to see that ellipse draw was called even if we called this through a base pointer, and this is classic polymorphism in C++. Again, the access specifier in the base class is going to matter. What you have in your derived class is going to be ignored by the compiler if you are going through polymorphism to call your methods through base class pointers like this. This is the point I want to drive home here. But if you go through direct objects, that's going to give you static binding, and you're not going to get dynamic binding or polymorphic behavior. So let's say that. So let's put up a simple example. We're going to create an ellipse object. It's going to be ellipse1. We're going to try and call our virtual methods on our ellipse object. And you're going to see that if we call func, this is going to work. But if we call the draw method, this is not going to work because the draw method is private in our ellipse class. If we go back, we can prove this. The draw method is private. You can see that right here. So if we try to call it from the outside, like we are doing here, this is going to give us a compiler error. Again, notice that we're not using a base pointer or a base reference. So this is not going to give us dynamic binding or polymorphism. This is going to give us classic static binding. And this is the behavior we have here. If we try and build our program, we're going to see that we can't call the draw method. This is going to give us this error here. It is going to say the draw method is private within the context of the main CPP file at line 15, which is what we are doing here. This is going to give us a compiler error. But if we take this out and build, this is going to build just fine, and it is going to give us static binding behavior. Let's try and put in a separator to be able to follow these things. We're going to say stdc out and put in a bunch of hyphens or dashes. That's how I like to call them. And we're going to build again and see what happens. We're going to pass this through GCC. Let's run the task to do that. The build is going to be good. We can clear and run Rooster. For the first time, we're going to get dynamic binding. We're going to call the ellipse draw method through a base pointer on line 9 here. And the second line of output here is coming from line 16 when we call func. And you're going to see that ellipse func was called because this is not dynamic binding. This is plain old static binding here. Now, if we try and go through direct objects and assign a derived object to a base object, the derived information is going to be sliced off, and we're going to only be left with base class information. So in here, we will lose all information relating to ellipse, and we will just have shape information in this object here. So this is again going to give us static binding behavior. If we call the draw method, it is going to be called because it is public in shape, but the func method is not going to be callable because it is private in the eyes of the shape class. This is the behavior we have here. We can also put in our separator here to make this super clear, and we're going to try and build. If we uncomment this line, this is going to give us a compiler error that you already know. You see we have a squiggly line. This is going to be private from this context here. We can't use this, but the draw method is going to be callable, and we're going to see that shape draw was called. Let's build and prove this. We're going to pass this through GCC. The build is going to be good. If we clear and run, we're going to get the behavior that we expect. Shape draw was called for ellipse 3, and it is our ellipse 3 object here that was sliced off to only leave in shape information. And this is really cool. If you want to prove these things, you can even put a breakpoint. For example, we can put a breakpoint here, and we can go to our run tab to debug a little bit. We're going to start our debugging session, and the build is going to be good. The generated binary is going to be passed on to the debugger, and we are going to hit our breakpoint in a minute. If we wait, we have hit our breakpoint. If we look at our locals, we're going to look at shape 3, and we see that it doesn't have any derived information. The only thing we have is shape information, and we just have the description, which is an std string. This is what we achieve with slicing here. This is really all I wanted you to see in this lecture, that the access specifier in the base class is going to matter if you want to use polymorphism, and the access specifiers in derived classes are not going to matter if you go through a base pointer or a base reference to access your things. We are going to stop here in this lecture. In the next one, we're going to explore how non-polymorphic functions work with different access specifiers in our inheritance hierarchy. Go ahead and finish up here and meet me there.